So these notes go with your page 127 in your textbook. Okay, so the first section is talking about speed. So we need to know what the bold words in our textbook are. Okay, specifically here, uniform motion is when you're going at a constant rate. You're not speeding up, you're not slowing down, okay, you're coasting, right? So imagining there's no friction, because friction does make you slow down or speed, and going down a hill, for example, on a skateboard would make you speed up. Okay, so this would be a bit more like a car, okay, where you have a steady input of gas and you're trying not to speed, you're trying not to go too slow and get rear-ended. Okay, so you've got the gas on cruise control, okay, on the highway, and you're going the same speed. Okay, and you also need to be going in a straight line for our calculations. Okay, so this rate of motion has to do with how far you go in a particular amount of time. So this whole unit of time thing has to do with, is it seconds, is it hours, is it years, right? So whether you're going on a car in kilometers per hour or light is traveling through space, right? That's going to be very different. Light travels a lot faster than a car. Cars travel a lot faster than people, right? So we need to make sure our units are right so that we don't crash into Mars with our space rockets and our Perseverance rovers. Okay, so the formulas we need are speed and velocity. And you're thinking, well, what's the difference? Okay, one of them has this little arrow on top. Okay, so let's take a minute to write that down on our formula sheets. Okay, so actually do it. And along the way, we're going to be writing our units as well. Okay, so let's start with the new things here. Okay, we had symbol, word, and what it's measured in. So speed, velocity, distance, and time. Okay, let's keep those slightly different here. So speed, velocity, okay, you're like, oh, that's the same. They're both D. No, they're different. Okay, these ones, it matters what direction you're going. So if you absolutely love all this stuff with calculations, take physics. Okay, if you want to be a rocket scientist, take physics. Okay, you might not be interested in every single teeny tiny detail. Okay, but if it needs to help you get where you're going, great. Okay, you might have some goals you want to reach. Okay, so time is the same, right? So this little delta means change in. Okay, change in time. So you're going to take your final distance minus your initial distance, your final time minus your initial time. Okay, so D1, D2, that's what this is all about. Okay, what's it going to be measured in? Meters per second for speed. Okay, you might have also heard kilometers per hour. Okay, but we're going to be mostly dealing with meters per second, I find. Okay, so velocity, meters squared per second squared, I'll show you that in a minute. Distance can be meters, and just like how we put up here 1,000 joules is a kilojoule, 1,000 grams is a kilogram. Nobody corrected me on that one. Okay, same with mass, or meters. Okay, so 1,000 meters is a kilometer. And then for seconds, sometimes we need to calculate seconds differently. So there's 60 seconds in 1 minute. Okay, and there's 60 minutes in an hour. Okay, and you're thinking, yeah, I know that. Okay, but sometimes you have to multiply your number because it's in hours, so you'd multiply by 3600. Okay, so we said meters per second, we said meters, we said seconds. Okay, and then we're also going to focus on something called acceleration. Okay, but that's not the first. Okay, the first thing we're going to work with is some practice problems. Okay, so take a second to actually write this out. Okay, and I will too. Okay, and you think, oh, I'll do it later. No, you won't. Do it right now. Okay, and some people are in the habit of just saying, tell me the answer. Well, the answer is right here. Okay, so it's not about the answer. Okay, you need to be able to do the process. Okay, so let's see if we have our notes on the process handy. Okay, let me find it for you. Oh, and we found our formula sheet too. Okay, let's add that. Okay, so we also have our formula sheet. Okay, we have the climate ones, we have the chemistry. Okay, let's give physics its own page. Because just today alone, I'm hoping we'll get through at least 4 of them, maybe 5. Okay, so let's go physics formula sheet. Okay, V equals d over t, so speed is distance over time. Okay, and I just want to make sure we write the similar format to the other formulas we did. Okay, what did we do special with those? Oh, okay, so we just put the rearranged versions of each. So let's do that on these ones. Okay, so that if you're asking for time, if you're asking for distance, that we could have it separate. And yeah, what I should do is I should take a picture of the climate one and then this one when we're done and send it to you. Okay, but you're making your own, right? And it's always good to have it in your own writing. It always seems to make more sense. Okay, so what would T be? T would be D over V. And if you need distance and they give you speed, you have V times T. Okay, and I'm just going to write it in 3 different ways. In case you see them with a little dot in between, that means times. Okay, and if you see them stuck together like this, that means you times them, you multiply. Okay, and how come I'm putting the T with kind of a little loop like this? You know, the little tail on the bottom? It's so that it doesn't look like a plus, right? Because if you put like this, that might be plus or it might be a T. Okay, so I put the little tail on the bottom to make it more obvious. Okay, there we go. We updated our formula sheet. Good for us. Okay, now let's go to our question and fish out some numbers. Oh yeah, that's what I was doing. I was looking for our process. Okay, so from a couple of weeks ago, which might feel like a couple of months ago, this is our process for no matter what formula we're doing. You always list your variables, write the formula, plug in your numbers with units, and then the last two steps is usually helpful too. Okay, so put the answer in a box with units and then write a sentence. So we went through this example before. Okay, I'm just going to go through it quickly in case you need to rewatch it in the video. So you list variables. In this question, we just used electricity as a sample. So the current was 5 amps, voltage was 10 volts, and we're trying to find out the resistance. So we said the current was 5 amps, the voltage is 10 volts, and the resistance is what we're trying to find. And we put the units because we know what we're trying to look for here. Okay, then we grab the formula we need. Okay, resistance is volts over current. Put the numbers in, put the answer in a box, and a sentence just to prove that you knew what you were learning. Okay, so that was really fast to go through this, but we're going to do this each time for our examples. Okay, so you'll totally get the hang of it if you felt way too fast. So, first step, 1, list your variables. Okay, so we got a number here, 1 here, and we have a question. How many minutes? Okay, so the only formula we learned for physics so far is V equals D over T. So that's probably what we're going to need. Okay, V, D, T. How do we know? It will tell us with the units, and sometimes it's even really nice, and they'll tell us right in the question. Okay, this says uniform speed. Isn't that nice? They told us the speed. Okay, so speed is V. So what does it say? 456? Aircraft, plane, they go a lot faster than cars, right? Okay, kilometers per hour. So even here, at the very top of the question, you put kilometers per hour. And remember, I don't care if you can just find the answer. Okay, the answer's on the question. The answer's in the back of the book sometimes for math, right? So I don't care about you being able to find the answer on this practice. Okay, what I care about is you being able to do the process. If you can do the process, you will always get the answer right. Okay, how many minutes? That's what we're trying to find. And they want the answer in minutes. Okay, now I can tell right away that's going to be a problem because we have a distance in hours here, or a speed in hours. Okay, so we'll have to do a conversion at some point. And then what's it saying? Will it take to fly this many kilometers? So that's a distance. Okay, so let's put that here. All right, there. Now we have V, we have D, and we have T. Okay, that's what we're looking for. So step 2, write the formula. So what formula are we going to use? We don't know. We just learned it. Okay, so let's look on our formula sheet that we just made. Okay, that's how come I have 2 notebooks open, or maybe you have 2 papers open, so that it's easy to refer back and forth. Okay, and if you want to make cute little note cards out of these, knock yourself out. Okay, so we're looking for T this time. So we need D over V. And we're writing them like this. Okay, I know you might want to write D divided by V like this, and it doesn't matter that much right now, but in terms of unit analysis, and especially for chemistry, I noticed, okay, you always want to write them one on top of the other, so not like that. Step 3, plug in your numbers. Okay, so T is D. Divided by, and I even had a friend who used a ruler every time. Didn't she do a nice job? Okay, distance over 456 kilometers per hour. Okay, now you ask the calculator what the answer is. Hello, calculator, where did you go? Here you are. Okay, 1534 divided by 4. See, this is why I love these calculators, is if you mess up, you just like push it back. Isn't that great? 456. Okay, and you get this big, beautiful number. Okay, let's write the whole thing down because Miss Bohaychuk said so. Okay, 3.3